Find the x and y intercepts and the vertical asymptotes of h of x equals x squared minus 3x over x squared minus 9. Here, we need to start by factoring the numerator and denominator because something interesting happens. In the numerator, we can factor out an x, giving us x times x minus 3. And in the denominator, we can factor the difference of squares as x plus 3 times x minus 3. And an interesting thing happens here. We have an x minus 3 in the numerator and the denominator, and those factors can be canceled, leaving us with a simpler version of the function x over x plus 3. So now we're going to look at the simpler version when we're looking for asymptotes and intercepts. But one important thing to note is that because we had a factor of x minus 3 in the bottom and the top, we know that the function is not defined when x equals 3. And so what this is going to do is it's going to give us a hole in the graph when x equals 3. So we're going to have a hole in the graph when x equals 3. This won't give us a vertical asymptote, and it won't give us an x-intercept. Because we have this factor in both the top and the bottom, it ends up creating a hole in the graph. So moving forward, finding the intercepts and the vertical asymptotes, let's look at the simplified version of the function. For the y-intercept, we need to look at what happens to the function when x is 0. When x is 0, we have 0 over 0 plus 3, which is 0 over 3, which is equal to 0. So the y-intercept is going to be y equals 0. Now, for the x-intercept, we know that this occurs when the function is 0, which happens when the numerator is 0, and in this case, that's going to be when x equals 0. Remember, this factor of x minus 3 is not going to give us an x-intercept because the function is not defined when x equals 3. So this is a special scenario. Lastly, we want to find the vertical asymptotes, if there are any, and we know that this occurs when the denominator is equal to 0. So in this case, we need to look and see when x plus 3 equals 0. This occurs when x equals negative 3. So our vertical asymptote is going to occur at x equals negative 3. Again, we will not have a vertical asymptote that corresponds to the factor x minus 3 in the denominator because it also appears in the numerator. When we have the same factor, like this, appearing in the numerator and denominator, this gives us the special situation of giving us a hole in the graph. So we'll end up having something like this when x equals 3. But we weren't asked for that. We were asked for the intercepts and the vertical asymptotes. We've listed those, and so we're done.